second derivative, actually it is very simple. First you need to take the first derivative, and then after that you will take another derivative, and you will be able to find your second derivative. So for example, here we have y is equal to x to the power of 4 minus 6x squared plus 5x plus 2. So what is the second derivative of y? So first we will start our first derivative, which is equal to 4x cubed minus, it's 2 times 6, it's 12x, and plus 5, right? And after that you will take another derivative, which will be your second derivative. So it will be equal to 3 times 4, it's 12x, 3 minus 1, it's 2, minus 12x, its derivative is equal to 12. Okay, if you take another derivative, it will be your actually third derivative, and you will write this as this, and it will be when you put these 2 in front of 12, it will be 2 times 12, it's 24x. Let's continue with this example. Here we have f of x is equal to x to the power of 10 plus 10 to the power of 10. So what is the 10th derivative of f of x? So this is actually equal to the 10th derivative of f of x. Okay, so in this kind of questions, let's start with the first one, second one, third one, and then let's see how it goes. Okay, so let's start with the first derivative of this function, which will be equal to, so here we have x to the power of 10, so I will put this 10 in front of x, so it will be 10 times x to the power of 10 minus 1, it's 9. Plus here we have 10 to the power of 10, since this is a constant, its derivative is equal to 0, so I don't need to write this. Let's continue with the second derivative. So here, now I have 10, okay, times, I will put this 9 in front of x, it's 9 times x to the power of 9 minus 1, it's 8. So let's take the third one, the third derivative. It will be 10 times 9 times, now I will put this 8 in front of x, times x to the power of 8 minus 1, this is equal to 7. Did you realize anything here? When you look at these, okay, but for example here, we have x to the power of 9, and this is our first derivative. You see, the sum of these two, it's 10. Also here we have 8 as an exponent, and this is our second derivative, and their summation is equal to 10. Also here we have 7, we have 3, which means when it goes like this, for example, the ninth derivation, okay, let's say we will have 10 times 9 times 8 times, it goes like this, and we will have x to the power of 1. Why? Because when we sum them up, it will be 10. Okay, so our 10th derivation is equal to, here it's 10 times 9 times 8 times 7 times, it goes like this till 3 times 2 times 1, which is equal to 10 factorial. Derivatives of parametric functions. So the relationship between the variables x and y can be defined in parametric form using two equations. Okay, so here for example we have x is equal to u of t and y is equal to v of t. So here t is called as a parameter. So we used to do, for example, y is equal to f of x, right? So here x was the variable in the function of y, but here x and y, they are two different functions, but they are not dependent on each other, but they both are dependent on t. Okay, so in this case, when you want to take the derivative of y, it's equal to dy over dx, which is equal to the derivative of y respect to t over the derivative of x respect to t. So let's look at this example. Here we have x is equal to 8 plus t squared and y is equal to 4t squared minus 5t to the power of 4. So dy over dx is s. As you can see, x and y, they are two different functions, but they are not dependent on each other, but they both dependent on t. So their derivatives will be written respect to t. So let's do that. Dy over dx is equal to dy over dt, which is the derivative of y respect to t. So it will be 8t minus 20t to the power of 3, okay, over over here we will write the derivative of x respect to t, which is equal to here 2t. So let's simplify this. When I take 2t parentheses, it will be 4. It will be 4. Yes, it's 4, and 4 minus 10t squared, okay, over 2t. So these will cancel out each other, and from here we will get 4 minus 10t squared. Let's look at these examples. Here we have x is equal to t squared plus 2t, y is equal to 3t squared minus 1. So what is the value of dy over dx when t is equal to 1? So as you can see here, we have x and y as our functions, and they both are dependent on t. So let's write our formula. So dy over dx is equal to derivative of y respect to t over derivative of x respect to t. Okay, so the derivative of y here is equal to 6t, right, and 3t squared, it's 6t, over the derivative of x, it's 2t plus 2. Now we will put 1 instead of t, so here we will get 6 over 2 plus 2, 4, which is also equal to 3 over 2. So this is our first answer. Let's look at our second example. Here we have x is equal to 5t plus 11 and y is equal to 2t cubed minus t plus 2. So what is the derivative of f of 1? So here you should be careful. Why? Because here this f is y is equal to f of x, right? So you don't put this one instead of t here. In this kind of questions, first you should find the value of t where it makes this x equal to 1. Okay, be careful. So because it is x the derivative of f of 1. Okay, so here this one actually our x. So let's do that. When I make this equal to 1, so this is 1 is equal to 5t plus 11. So when I put this 11 to other side, I will get minus 10, which is equal to 5t, and from here t is equal to minus 2. Now after finding its derivative, I can put this value instead of t. Okay, so let's do that. So this will be dy over dx. So this is dy over dt over dx over dt, which is equal to here. Let's take the derivative of this one. It's 6t squared minus 1 over here we have 5, right? Now I will put this minus 2 instead of t. I will not put 1 instead of t, okay? So this one is actually our x value. Don't forget this. And now I can put this minus 2. So it will be 6 times minus 2 squared. It's 4 minus 1 over 5, which is equal to 6 times 4. It's 24 minus 1. It's 23 over 5. Let's continue with derivatives of implicit functions. So what is an implicit function? For example, when we have y is equal to f of x, okay, we know that this y is dependent on x, right? So in implicit functions, it has actually several variables. It can be x, y, z, okay? For example, in our example, we have f x y, so is equal to 0. So here, as you can see, our f function, it is dependent on x and y. So when I want to take its derivative, it's equal to minus the derivative of f respect to x over the derivative of f respect to y. Let's look at this example. Here we have f x y is equal to y to the power of 4 plus 2x square y square plus 6x square, which is equal to 7. First, you need to make this equal to 0. Okay, so let's put the 7 to other side. So f x y is equal to y to the power of 4 plus 2x square y square plus 6x square minus 7 is equal to 0. Okay, first it has to be equal to 0. Okay, now let's find its derivative. So the derivative of f of x y is equal to minus fx over fy, right? So this is the derivative of f respect to x. So I will look at the variables with x. Okay, so this will be equal to minus. So let's look at here. We have here y to the power of 4. So when we take the derivative of f respect to x, we think these y's as a constant. Okay, so here we think this as a constant. That's why its derivative is equal to 0. So we don't take this. Let's look at here. We have x here, so it will be equal to, when I put this 2 in front of this, it will be 4x y square. You see, still we think this y as our constant, plus here also I have x, so its derivative is, when I put 2 in front of this, it will be 12x, right? Since this is constant, its derivative is 0. Okay, we will do the same thing for y, but now we will think our x's as our constants. Okay, so first one, we have y to the power of 4, so its derivative is 4y cubed, right? I put this 4 in front of y, and I will just 4 1 1, it's equal to 3, plus, let's look at here, we have y also here, so we put this 2 in front of here, so it's 2 times 2, it's 4x square y. You see, here also we think this x as our constant. So here we have x, that's why it's 0. We still think this as a constant. And here we have a constant, its derivative is equal to 0. So this is all equal to, let's put this minus here, it's minus 4xy square minus 12x over, it's 4y cubed plus 4x square y. So when I take in parentheses 4, it will be x y square minus 3x over y cubed plus x square y. So this is the answer for our example. Let's look at this example. Here we have sine x plus cosine y is equal to x plus y plus 1. So what is the dy over dx? So as you can see, we have two different variables here, x and y. So this is an implicit function. Okay, so let's rewrite our implicit function here. It's fxy is equal to, let's put all these on one side and make this equal to 0. Okay, so it will be sine x plus cosine y. Let's put them to this side, and it will be minus x minus y minus 1. These are all equal to 0. Now I can take the derivative of f of xy. So let's do that. This is equal to minus the derivative of f respect to x over the derivative of f respect to y. So this is equal to, let's write, it's minus, so let's see, sine x, its derivative if is cosine x, and this is 0. Here we have minus 1, right? Over here we have cosine y, its derivative is minus sine y, and here we have minus y, which is equal to minus 1. So when I multiply this minus with this, our final answer will be cosine x minus 1 over sine y plus 1. So this is the answer for our example. And we have a question for you here. So please leave your answer on the comment section and we will read each one of you.